for another session. For this session, I have my colleague Tom Vanheertum, who is dialing in from the Netherlands. Hi, Tom.
Hi, Daria. Hi, everyone.
Hi. Tom is going to talk about bio-based products with focus on waterborne for industrial wood and decorative. Don't forget to ask your questions on the right-hand side of your screen in the chat box. With saying that, I would like to hand over to Tom.
Everyone. Um, Nice to see you all again. It's my second presentation. Today I'm going to talk about something else than packaging. We're going to discuss a little bit about our options in the range of waterborne for wood and decorative applications, and how to increase bio content and reduce the carbon footprint of your coatings. So if we go and discuss about what is going on in the industry in terms of labeling and requirements, we see a lot of new things popping up recently, which are initiatives which generally look at how to increase carbon footprint. They try to assess the sustainability characters of a coating or a product that is put on the market by either asking for a true bio content, a product carbon footprint like LEED and BREEAM. For building certifications, there are things I think we talked about as well as ICC trying to certify where bio content is coming from, and trying to manage the whole value chain, making sure that nobody's cheating the system. Now, when we look at waterborne products and the products we put on the market, if you look at waterborne, and the nice thing about the producing of waterborne polymer dispersions is, if you look at a process called emulsion polymerization, you use actually a lot less energy than what you would normally do with other solventborne type of processes. So monomer droplets are dispersed in water, which is almost without energy, except of stirring, of course. Micelles are formed, and then the polymerization process takes place, and you end up with dispersed polymer droplets in water, which then later on, of course, need to form a film. These films can form at, of course, depending on the MFT, at very low temperatures, so you don't need a lot of additional energy in the curing of these systems, and that's also why you see them being used a lot in decorative and field applied settings, but also in industrial settings for furniture or joinery, for example, where of course players are very aware of their energy bill, and probably more today than in the past. When we look at ingredients, when we look at the design of the product, but also the process, we try to look at our raw materials, making sure that there's no hazardous substances there. Of course, with waterborne, you always have to take care of contamination and so on. So things need to be checked. That can, in some cases, cause issues with labeling. But in general, we try to have a look at when we produce, if we have to use energy or in energy intensive processes, we try to make sure that we optimize our sorting strategies, that we use as little as possible through fossil sources. So we try to watch our carbon footprint there. Moving to the next slide. So we introduced this concept, which is really also known at for example, players like IKEA. We call our better carbon concept. And better carbon, what do we understand with better carbon? Better carbon for us means products that can be certified through the C14 method. I think that's already discussed a couple of times in the last few sessions. So that can be either through using a drop-in monomer or using a new building block. Those new building blocks are very distinct and different from what we have been using in the past, which was, I would say, a very elegant fossil chemistry where naturally derived raw materials can sometimes be a little bit more complicated, also more complicated to use in production. And then there is, of course, the easy way, I would say, where you can use mass balance with a monomer or a polymer, which is chemically exactly a twin of what you would use today, and therefore you just need to make sure that your bookkeeping is okay. And this is done by using, for example, the ICC Plus method for people in the value chain who have this certification. On the other side, of course, there's also recycled monomers which you can use. Again, some monomer suppliers have adopted ICC Plus or will adopt ICC Plus. In other cases, we might certify these ourselves just to make sure that you get really the product we promised. Now, looking at our better carbon roadmap. So what have we been doing in the past, and what is our plan tomorrow and the day after? So if we look at our portfolio today, resins, waterborne resins that is, that have a renewable content, we can divide them in a couple of categories. So the first category is our waterborne acrylic hybrids. These products are modified with natural resources like fatty acids and oil modifications. They give you a better carbon content or a bio-based content of around 7%, which, if you look at an acrylic, it's not too high, but it's at least bio content, which in an acrylic is really not that easy. So why would you use these type of products? These two products are mainly for exterior use. They give a nice body and gloss to the system, better gloss than a standard waterborne acrylic would in the same application. You can use these without dryers, where you would have to use a dryer in an alkyd, obviously. So again, that is a sustainability aspect in this sense. Then we have the waterborne modified alkyds. Looking at modified alkyds, of course, we all know that alkyds are derived from natural oils. And of course, this is really where the bio content comes into. So you also have to know that we recently launched, of course, our mass balance penta range, which we'll be rolling out, which will boost this bio content even further. Looking at these products, again, these are really products which are used in a decorative environment. A lot of them have been developed in the past for opaque or transparent textile type of applications. If we run through the list quickly, there's like the grandfather of all resins of our waterborne alkyd portfolio, which is the AY586, which is a general use type of resin. You can basically formulate a very nice deck stain. You can add it as an additive. It gives you a nice open time, nice gloss, and so on. Of course, all of these products, again, they work in combination with a dryer. 6705 is another grade in our range, which is slightly more hydrophobic than 586, and it has an acrylic modification, which makes it so that it dries a lot faster than 586 would do. So with the acrylic modification, you get a slightly better UV resistance performance than you would with 586. Then we have 6191, which is again a hybrid product. This product has a PU modification as well as an acrylic modification. So with the PU, you get slightly better chemical resistance levels, and you get the better gloss than you would with solely an acrylic modification. 6710 is then a product which is again slightly faster. It gives you also good gloss, and it's really a good top coat resin. Then there's Residrol 5547. 5547 is a modified linseed oil product which you can use for transparent solutions. You can use it as a waterborne teak oil, for example, so it gives you a very nice penetration in wood. You can also use it in combination with certain fungicides or biocides to make sure that your wood is not rotting later on in the process. So following through from what we had commercially, and we started to notice that, okay, we are really leaning onto one or two applications here. So is there anything else we can do in our range to both expand our portfolio in application, but also look at different technologies? And that's where Setaqua PU1160 and the hybrid BB6270 come in. These are real polyurethane dispersions or hybrids of these, and these give you a much better taper abrasion resistance, so they're really products. The 1160 you would use, for example, in a flooring formulation or as an additive resin in furniture and deco applications, where the BB62 is more of a product which is more cost efficient. It'll give you better properties than a standard acrylic would do. Gives you very fast hardness buildup and so on, and good film clarity, but obviously is a lot cheaper than a pure PUD would be in the same application. Then this is the things that we are really doing now today and hopefully rolling out by the end of the year, early next year. And that is really bringing into the equation the mass balance and the recycled monomers. And based on that, we developed a couple of products. So you can see here we have the 6710 recurring again. But again, this time we will boost the bio content by using mass balance. Acrylic monomers in this case. There is the Setaqua 8800, which is a very general use acrylic. You can use it in decorative trim paints, also in furniture, primer, sealer, and top coat. It's a very fast product, I would say, so it dries very fast, gives you good blocking resistance. Hand cream resistance is very nice. The chemical resistance is decent, but okay, it's not in comparison to a waterborne UV product or something you could reach IKEA R2 with. But in general, also in combination maybe with some PUs, you could get really good top coat performance of this. Then there is Setaqua BB 8850. 8850 is very similar in properties to the 8800, but you can see here that the bio-based content, and this is the bio-based content you can actually measure and verify through C14, is 29%, where the total bio content is 60%. With the 800, you see that there is a better carbon content of 80%, which is very high. And this is through the combination of using both recycled and biomass balance monomers. Then there is the BB 6274, which is again a PU hybrid. This product again shows a very high better carbon content, which is coming from one part the PU modification, and the other part is coming from, again, a combination of biomass balance and recycled monomers. So that's really a cocktail of all we have in-house to balance bio content and performance. If you want to know more about waterborne UV PUDs and the bio content of those, obviously there was already the presentation before this one with Cedric, but later on Michelle will also dive into a bit more detail on the waterborne UV side of things. So nice. Okay, now we know the bio content of resins, which is all very nice, but ultimately it's also end users who want to see what the bio content of their products will be. And I feel like sometimes we have to explain this in a bit more detail, because what we noticed is with customers, they say, I buy a product which has 40% bio content or 80% bio content. I'm only using half of it in my formulation, so does that mean that the bio content of my formulation is only 40% instead of 80%? And that's not the case. So what you really need to do is, again, figure out where you are with your renewable carbon. So you have to try and assess, and you can do that by using the bio content combination with the non-volatiles, or you can check with us how you need to calculate. But basically you start off from the total carbon in the polymer backbone, try to calculate the mass out of that, and then you calculate the renewable or the bio-based carbon mass in that product, and that will give you a wet and a dry state bio content. You can do that for a coating. So in this case we have a top coat based on the Setaqua 8800, and we have a sealer based on the Setaqua 8800, so you can see both examples here calculated. Then if you look at, for example, if you're selling a product to IKEA, you can sell the product in different systems, either by using a sealer, a primer, and a top coat, just doing a slightly thicker primer and a top coat system, or having less sealer with a primer and a top coat. And that gives you, again, the wet and the dry bio content of your total system buildup. So you can see with the 8800, you basically pass the bar at IKEA until 2030, were it not that IKEA would like to see true C14 certifiable biocontent by 2026, I believe. So that is where products like the 8850, the 6270, 6274 will have to come in to really pass the bar at IKEA. So those products will come out of the pipe very shortly. So hopefully this will create a lot of excitement for customers who are active in the furniture industry that would like to play a role at IKEA. So with that, I conclude my presentation. So again, I open the floor to more questions. I guess, Daria, you will moderate?
Yes, I will moderate, and we have some questions in the chat. Let me pick up one. What is the recycled content for the resins you introduced?
So we actually don't want to go too much into detail with the content of recycled versus true bio content, because that would divulge too much of the information of the composition of our resins. Later on, when more availability is there in terms of recycled and actual bio-based products, we might change that. But for now, we will keep that information confidential.
Thank you very much, Tom, for answering this question. And we move to the next question. When will these products be available on the market on a large scale?
So there we're really planning to move the Setaqua 8800 in the near term. So hopefully we will be ready with upscaling by Q4 of this year. There are some sourcing issues we have to get out of the way. So we hope by Q1, Q2 next year, we can be supplying bigger volumes to the market, which if you start testing today, you probably take a couple of months to get your resin and your coating homologated. So we should be ready by the time anyone wants to see bigger volumes.
And we move to the next. Our attendees think that certified products are truly sustainable. Should mass balance not be considered as a cheating thing?
Yeah, again, I mean, we had the conversation this week again. I think Sanita and Simon had a nice presentation about this. So I invite you, if you want to really know a bit more detail, to have a look at their presentation. But yes, I mean, certified product is something you can see in your hand, right? So if you certify something, you can see that there is a content, it's tested, it's there. The advantage of mass balance, I would say, is again, you also are certain what you're getting, because ICC really guarantees that everyone in the value chain is doing what they need to do. It's audited to a third party. So the system is rather foolproof, and you can really trace it back to the source without anyone having to disclose the confidential information about product composition. So that also is relevant for the coating manufacturer. So also there, they can have a certificate without having to split out their raw materials and giving too much information to their customer and potentially competitor.
Thank you very much, Tom. And we move to the next question. What certification system will issue the bio or sustainability certificates?
So again, this certificates that will be ICC. So we are planning to move these together with a COA, which will be generated by every batch record. And then at month end, we can send customers a summary of what we've been sending to them, which is then verified with us at the raw material source.
Thank you very much, Tom. And we move to the next. Do you have the carbon footprint available for the products?
Yes, we had a look at a carbon footprint of our products. Those products are now calculated on the data we have available today. So we're still trying to figure out from some of the suppliers this true carbon footprint. So part is now based on the database and part is based on supplier data. Upon request, we can disclose this carbon footprint, yes.
Thank you very much, Tom. And let's move to the next question. Have you got any resin with MMFT more than 40 degrees, with BB more than 40%? You have to help me with acronyms.
A good question. On the MMFT, I'm not absolutely sure. I think most of the resins I've been showing here do have an MMFT actually below 40 degrees. So what you would be looking for is something with a higher MMFT. We are currently looking at indeed also other industrial type of resins which higher MMFT, which would also have a better carbon content. But today I don't think we have one in development.
Thank you, Tom. And let's move to the next question. Do you have a rough comparison about the different technologies? What is meant is, are waterborne acrylics better than solventborne? And how is rated the technology of short oil alkyd cured by aromatic isocyanates versus 1K waterborne acrylics?
Yeah, that's a very complicated question. So there's a lot of parameters here we have to look at, of course. So one of the things is, how are the resins or the coatings being applied? How are these being produced, and what are the inputs for production? So if you look at process-wise, solvent-borne alkyds, for example, they are very energy intensive. So it's a polycondensation process. You typically, what we say, maybe dates back to the olden days, we cook an alkyd at over 200 degrees C. And you do that for extensive period of time, over 15 to 20 hours, for example. So that's very energy intensive. If you look at a waterborne acrylic, batch times are much shorter. You need less energy to do so. So in that sense, a waterborne acrylic is probably more sustainable. On the raw material side, of course, an alkyd is bio-based, where an acrylic might not be. But there is where we open up the floor for the mass balance and other biomonomers being used. So in that sense, yes, there is a big difference in how you should assess. Elwin did a nice presentation on automotive side, and we're really digging into more detail on how to compare on the application side of things. If you then start to bring in the isocyanates to the equation, of course, also there is a lot of energy involved in the system. So there you can see that probably a PUD process-wise is slightly worse than a waterborne acrylic would be. So it really depends. There's a lot of detail involved, and that's of course also the product carbon footprint calculations that we're actively pursuing and making sure that we have all of that on stream for our customers in the future.
Thank you very much, Tom. And we move to the next question. Is there a bio-based alternative for Setaqua 6754?
Today there is not, but I would say not yet. So this is really one of the resins we also have in mind, because we see there is a large demand for it because of the chemical resistance. And again, I think it sort of correlates a little bit with the MMFT question. So that's really something we will be looking at in the future. Yeah. So please find us if you have a demand for this. We'll happy send you a sample once this product is available.
Thank you, Tom. And let's move to the next question. Are there comparisons available between fossil sourced binders and bio-based binders?
Sorry, can you repeat the question?
Sure. Are there comparisons available between fossil sourced binders and bio-based binders?
Yes, so for the developments we're doing today, of course, we look at our portfolio which we have in the market today, and we try to not give in anything on the performance. If possible, we'd like to even improve, of course. So we really want to counteract that old adagio that bio-based product or a recycled product is worse than a standard version. So we have comparisons available, but of course we don't compare every development we do with our total resin portfolio. So it depends a bit what information you're looking for. Again, if you want to know more, please contact us, and we'll try to get that answer there.
Thank you very much, Tom. And we move to the next question. What about the pricing? How does pricing look in comparison to fossil-based products?
Yeah, a nice question. I mean, it's. I think we have to be clear and honest about this. So if you look at the raw material market today, who is producing the real bio-based, and if you're talking about acrylic monomers, that is, who's really producing these? These are relatively small producers at small scale, where the fossil producers are producing at really almost megaton scale. So you're comparing a 20 kiloton plant with a million kiloton plant, which of course on the operational side brings a lot of cost if you're producing small scale. On top of that, some of these precursors, which are made from agricultural waste, they can be fermented and so on. Again, that's all small scale production. There's a lot of transport involved. Not that the transport is very bad for the footprint, but if you really look at it, it's not as an efficient process yet. So the real bio-based products, I would say, carry a hefty premium. So there we see raw materials for us times 3, times 4 in certain cases. If you look at biomass, those are way more energy efficient, and there we see producers are being more, let's say, acceptable with price premiums, but still, I mean, they're not small, 50 to 100% typically. So also, yes, these resins will be slightly more expensive, unfortunately, than the fossil ones, but you can't change anything if nobody's investing in the value chain, and somebody needs to pay for the investment for people to actually change something. So I think it's really all of our responsibility to contribute there and to end up with a better environment.
Indeed. Thank you very much, Tom, and you covered it all.
Okay, thank you.
Thank you again for dialing in for your presentation, and thank you everyone for asking your questions. See you in the next session. Bye-bye, Tom.
Bye-bye.